Hello, my name is Mr. Koda, and I have Ms. Ko behind the camera here, and I'm going to give you a short lesson on translating chemical reactions. But before I do that, I want to do a little bit with some blocks that I have in front of me, and then we're going to relate the blocks that I'm going to be looking at with a chemical reaction equation that's up on the board, and hopefully you can see that. Let me begin with the blocks, and let me give you an explanation of what the blocks represent. So right here I've got two blocks and I have them put together, and these are going to represent a molecule, and in fact it's going to be a hydrogen molecule. So one of my red blocks is an H atom, or a hydrogen atom, and then here's my second hydrogen atom, and we put them together and we get something called H2. And you'll see that I have H2 written on the board, and we'll get back to that in a second. And I want you to notice that I have one hydrogen molecule, and in fact, here's a second one, and then a third and a fourth. So I've placed 4 hydrogen molecules on my desk in front of me. And then if I come over here and I take a look at the 2 blue blocks that I have, one of them represents a single oxygen atom, and then I have a second oxygen atom, and I'm going to put these together. And this is going to make an oxygen molecule. And this is going to be represented as O2. And I've written O2 on the board here, and we'll get to that as well. And you'll notice that I've got a second oxygen molecule, and this one has a blue block and another blue block, 2 oxygen atoms stuck together to make these 2 oxygen molecules. And what I would like to do is I want to talk about how this looks and how it relates to what that looks like up there on the board. So here's what I like to tell my students. I like to tell them that the first thing to recognize on a chemical reaction equation is this arrow right here. Because the arrow tells you to divide it into 2 parts, a before and an after. So what I want to do is talk to you about the before, which is everything to the left of that arrow, and the after, which is everything after that arrow. So let's pretend I'm taking a camera and I'm going to take a snapshot of my oxygen molecules and my hydrogen molecules. That snapshot is the before. So if I look at what I have here and then show you what I have here, they should be very similar. I have hydrogen, H2, that's this, and I have oxygen, O2, and that's this. And so let's take a snapshot and show you I've got hydrogen and oxygen, and we're going to change it into water. So first snapshot taken, I'm going to take my oxygen, I'm going to break it apart. The chemical reaction is now happening. Okay, so I'm going to break that apart, I'm going to break that apart, and I'm going to take 2 of my hydrogens and connect it with 1 of the oxygens, making a model of a water molecule, H2 and then an O, which is my H2O here. And so if I do that 3 more times, I get a total of 4 water molecules. And if I take a snapshot of this after, I now have this part of the chemical reaction. And so these 2 parts, the before and the after, have a specific name that I need you to remember. So let me write up on the board what I need you to remember with this. These 2 things are called reactants. The chemicals before the reaction happens, they're called reactants. Now after that snapshot happens on the second time, these are called products. And in this case we have 1 product. So reactants and products. So my H2 is a reactant, my O2 is a reactant, my water, my H2O, is a product. Now that's the preliminary thing that you need to know for looking at one of these things here, which is called, in chemical, reaction, spell it correctly, equation. One of these things with an arrow in it, this is a chemical reaction equation. Now you'll notice that there are a couple of things on the board that I never talked to you about, and I want to talk to you about them now. They're related to symbols, some symbols and their meanings that you need to know. Well, we first talked about that little arrow right there. And that arrow gives you a before and an after view. That arrow has a name, or it has a translation. So let me translate this for you. And there are a couple of translations for you. Reacts to form, or it also means yields. So anytime you see this arrow in a chemical reaction equation, I want you to translate it as reacts to form or yields, either one. Now, here are some of the other symbols that are on the board that I need you to know. This little plus sign, many times students will say, oh, that's a plus sign, it must translate to plus, and it doesn't. It translates to the word and. So if you see a plus sign in a chemical reaction equation, I want you to translate it as and. Now let's take a look at a couple of, well, I only have one little symbol here. I have a little symbol, a little subscript with a lowercase g inside two parentheses, and you'll see it in 3 different spots here. This indicates that whatever the molecule is, or the formula in front of it, that happens to be a gas. So this is hydrogen gas. Let me translate this as hydrogen gas. The gas is for the little g in the parentheses. And you'll notice that there's a little g in parentheses here for the oxygen, so that translates to oxygen gas. Let me write that here. Oxygen gas. And again, you'll see that the water happens to be a gas as well. And we'll talk about why it's not a liquid in a moment. But if I want to translate that, I might say, well, let me stop for a minute, because sometimes you could just say water gas, but normally if you have some experience with water that's gotten really hot, you might call it steam. So I could translate this to just steam, but just for consistency, let me just call it water gas. And so the term gas translates to the little g in the parentheses. You will not always see a little g in parentheses. Let me give you some other examples of things that you might see in a chemical reaction equation that are subscripts. Here are some other subscripts. You find some space down here. You may see small parentheses, a little aq. This translates to aqueous, meaning, and let me give you a little translation on that, dissolved in water. You may see a little parentheses and a lowercase l. This is not a 1, it's a lowercase l. And that stands for liquid. And if you were sharp, you were paying attention, you might think to yourself, hey, why don't I put this here? And sometimes you will see a little L, maybe next to water, in a chemical reaction equation. And you would have the small parentheses and the little L in there, and that would stand for liquid. Now, there's another phase that you probably should be familiar with, and it has a representation of 2 small parentheses and a small s in there, and that translates to solid. So you need to know what the solid means. And let me add just one more symbol that I'd like you to know about, which actually relates to why I had put this as a G rather than an L. That's this triangle above the arrow. The triangle above the arrow indicates that heat was present during the chemical reaction. So I have H2 gas and O2 gas, and then in the presence of heat, that triangle means in the presence of heat, water is formed. And if it's hot, the water that's formed will be in the gas phase, not the liquid phase. Okay, so let me write, let me put down here, triangle translated to in the presence of heat. Now, quick summary. We've given you an introduction to chemical reaction equations. Here's an example of one right here. There are several little symbols that you need to know what they translate to. The large arrow means reacts to form or yields. The triangle above that arrow indicates that it reacted in the presence of heat. And then there are some subscripts you need to know. Little g in parentheses for gas, little l in parentheses for liquid, little s in parentheses for solid. Something that happens to be dissolved in water is called aqueous, represented by the little parentheses with an AQ, lowercase aq. And the last thing you need to know is that that plus sign